All right, so yesterday we left off and we watched the video of the mega whoosh slide where the guy had gone down the slip and slide and then off the ramp and landed in the little kiddie pool, which was, on first glance, cool looking. On further exploration and thought, calling you know what on that one, okay, is that that's just not, sure, I could put the pool where he would hit it, but he'd still die. Okay, because there's no way that pool has enough water in it to absorb the impact of him flying into it the way he did. Okay, I mean, you think of how much of a splash you'd make in a pool and how far you would move in the pool, okay, after just jumping off a small diving board. Okay, what he did would make a much bigger disturbance in the amount of water that he had. Okay, and then we did this calculation here. Okay, I didn't save it, unfortunately, but okay, we did the calculation that proved we could figure out where to put the pool that he would land in it safely. All right, so what we're going to do now is we're going to watch the Mythbusters bust this thing, okay, because they actually did a whole episode on this video. They built the slide, okay, and they did the whole thing. Okay, it's really quite cool. Okay, they did the calculations. There's a lot of stuff that went into kind of debunking and busting this myth here. So yesterday we talked about both kinds of projectile motion, but we really only did a couple of questions with the you run horizontally off of a cliff kind, okay, not the angled kind. So, okay, this is an example of one of those ones where something runs horizontally off a cliff, okay? They're asking, the question this time, instead of asking where they land, is saying, here's where they land, how high is the cliff? All right, so you're working a little bit backwards. So just a couple of reminders on what we want to do here. First, we want to kind of draw this out. All right, we know that the person is going to run off the cliff at 8 meters per second, right? Is that a horizontal or a vertical value? That's a horizontal value. So we want to remember that we also want to break this thing up into the two components. Okay, so vertically speaking, or sorry, horizontally speaking, okay, we know that the speed is 8 meters per second. And we also know that they hit the water 15 meters from the base of the cliff. Horizontal or vertical? That's horizontal because it's saying here's where they land. That's a horizontal value, 15 meters. Okay, so we know the horizontal distance is 15 meters. From a vertical perspective, we know two things. What do we know? Acceleration. We know acceleration. 9.81 meters per second squared, and what else? Which is 0, right? So our initial velocity is 0 meters per second because we ran horizontally, okay, meaning we had no initial vertical velocity. All right, with that information, I need to find how tall the cliff is, which is essentially the vertical distance traveled. All right, I'm going to give you guys a couple of minutes here and see if you can figure that one out. All right, then we'll walk through it together. So if I'm going to calculate how far this person falls, what variable do I need? Time. Okay, and in projectile motion problems, time is the most important variable because it's the only one that's shared by the horizontal and vertical components. Now, can I find it with the information I have? Yes, the horizontal information can help me to calculate it because I know horizontally the person is traveling at a constant speed. So I can use v equals d over t. So t will equal, okay, d over v. So that'll be 15 over 8. Okay, so we're going to get like 1 point something seconds here, right? So we're going to 15 divided by 8. Okay, so there's our time, 1.875 seconds. So that means that's how long they fall for as well. Now, do I have a formula that'll calculate d with these other three variables? Yeah, this one. D equals vi times t plus 1/2 at squared. That's 0, so I can get rid of it. All I have to do is plug in 1/2 times 9.81 times 1.875 squared, and I will have the height of the cliff. So 0.5 times 9.81 times 1.875 squared. Whoop, missed the decimal. All right, so the cliff's 17 meters tall, okay, is what we've got there. That sort of makes sense? There's really only two things a horizontal one like that can ask you. How far from the base of the cliff do they hit the ground, and how tall is the cliff? That's really about all you're going to be asked. Maybe you could also be asked, at what speed did they run off the cliff at? Okay, it would probably be about the third thing that you could be asked for, which would just mean you'd solve for t and then work back to get v instead. Right? They would have to tell you how far from the base of the cliff you hit the ground. All right, is that making some sense? All right, so tomorrow, okay, we'll be working on just projectile motion stuff. We'll talk some more about the projected at an angle ones, like the mega whoosh there. Okay, there's a couple more videos that we're going to watch to do with that, but mostly we'll be working on that stuff tomorrow. Okay, as well as on Thursday and Friday. Okay, so unit exam review, guys, will be next week on Monday. Okay, we'll do that and then have the exam Thursday.